10 astounding details about the solar system. Hello and welcome to Z. 10 astounding facts about our stunning solar system are provided below. I sincerely hope you all enjoy this video. 1. There are currently known to be 1.113.527 asteroids, sometimes known as minor planets, are stony byproducts of the early solar system formation, which took place about 4.6 billion years ago. Although a few asteroids are almost spherical, the majority of asteroids are asymmetrical and frequently pitted or cratered. The asteroids also rotate, occasionally rather wildly, tumbling as they go through their elliptical orbits around the Sun. It is known that more than 150 asteroids have a tiny companion moon, some have 2 moons. There are also triple asteroid systems and binary, double, asteroids, in which 2 stony bodies of nearly identical size orbit one another. The strong gravitational pull of Jupiter and occasionally close runs with Mars or other objects have the power to alter asteroids' orbits. These collisions have the power to eject asteroids from the main belt and launch them across the orbits of the other planets. The geological history of the planets and the development of life on Earth have both been significantly impacted by stray asteroids and asteroid pieces that have collided with Earth and other planets in the past. Earth-crossing asteroids, whose tracks cross Earth's orbit, and near-Earth asteroids, which come within about 28 million miles, 45 million kilometers, of Earth's orbital distance and may be dangerous if they collide with it, are constantly monitored by scientists. Radar is a useful instrument for identifying and keeping an eye on potential impact risks because it can generate images and other data from the echoes of sense signals that bounce off objects. An asteroid's orbit, spin, size, form, and metal content can all be discovered by scientists. Jupiter is orbited by a class of asteroids that is well known. Around the so-called Lagrangian points L4 and L5, there exist creatures known as Trojans. The phrase Trojan asteroid was created when it was determined to give all asteroids found near Jupiter's L4 and L5 points the names of Greek and Trojan fighters from the Trojan War, respectively. The 2 Trojan asteroids that were discovered and given names before the 2 camps were created are Hector, a Trojan spy in the Greek camp, and Patroclus, a Greek spy in the Trojan camp. The L5 group of Trojans appears to chase the L4 group when viewed in the Jupiter rotating frame, like 2 groups of soldiers chasing one another. In relation to asteroids. 2. We altered an asteroid's course within the solar system. The past million years have seen it in orbit. We arrived there, struck it, and altered its course. Dimorphos, the tiniest asteroid in an asteroid binary system, is the subject here. The bigger one is known as Didymos. DART, the mission created for the task, was dispatched to this system to crash the asteroid. The result of this collision seems to indicate that the method might be effective if we need to deflect a truly lethal space rock. Just after 7:14 p.m. Eastern Time on September 26th, DART collided with Dimorphos, which was about 7 million miles from Earth. The spacecraft was hurling at the moonlet at a speed of around 14,000 miles per hour while frantically taking pictures of its intended target. Dimorphos expanded over the course of a few minutes from a fuzzy clump of pixels to an egg-shaped, boulder-strewn miniature world that covered the spacecraft's field of view. As the final image was being transmitted, the transmission abruptly ended. 3. Composition. The inner planets are stony, but as you travel further out, planets start to become gaseous, which is another astounding aspect about the solar system. Ever notice that, do you? The solar system's formation is what gives the planets and other celestial objects in our solar system their specific positions and configurations. Only stony material could resist the heat in close proximity to the Sun when it was still young. The first planets, Mercury, Venus, Earth, and Mars, are terrestrial planets as a result. They all have rocky, flat, and tiny surfaces. In the meantime, substances that we are accustomed to viewing as ice, liquid, or gas settled in the solar system's outermost regions. The ice giants Uranus and Neptune, as well as the gas giants Jupiter and Saturn, were brought together by gravity. 4. The solar system's patterns. We may all agree that Copernicus was correct in his theory that the planets orbit the Sun. Our knowledge of their elliptical trajectories comes from Kepler. Since these orbits can be represented by mathematical formulas, they have certain attractive geometrical characteristics, at least in the short term. You might discern that they are essentially a harmony if they were plotted using the appropriate reference system. What would happen, for instance, if we charted the planet's orbits in relation to where the Earth is in space? The velocity of Venus, however, has a very observable rhythm. It returns to the same location in our sky on or around the same date after 8 years. This is referred to as Venus' 8-year cycle. Ancient peoples like the Maya were well aware of this cycle. Many people today refer to it as Venus petals or the pentagram. The term pentagram is used because each phenomenon, each change in the relative positions of Earth, Venus, and the Sun occurs 5 times during the course of 8 years. Then, they repeat 5 times nearly indistinguishably during the following 8 years. Venus is not the only planet, though, that exhibits intriguing patterns. Except for Neptune, all of the planets in the solar system have the following patterns. The Mercury design is one of my favorites. How do you feel? 5. Sun-grazing comets. Some comets occasionally pass quite near to the Sun. They have been studied for many centuries and are known as sun-grazing comets. Heinrich Kreutz conducted research on these comets in the 19th century. He realized that every sungrazer orbit that had been found up until that point had followed the identical orbit. They all appear to have been pieces of a single comet that had fragmented, according to astronomers. As it circled the Sun, the initial comet was likely frequently fragmented. Today, this collection of comets is referred to as the Kreutz sungrazers. But why are there such comets? How do they manage to get so near the Sun? The three-body problem, it seems, is the answer that solar system dynamicists are looking for. In fact, when there are more than 2 bodies orbiting each other, their gravitational fields interact and all kinds of strange things occur. The so-called Lyapunov migration is one of them. It is a dynamical phenomenon that, under specific circumstances, affects the orbit of a binary system whose motion is disturbed by a far-off third body. In our scenario, the binary system is Comet Sun, and Jupiter serves as a perturber. According to this model, Jupiter excites and disturbs the comet. As a result, the comet's orbital parameters are altered, gradually bringing it nearer and nearer to the Sun. As a result, a non-sungrazer comet may turn into one. 6. A view of the solar system from Proxima Centauri. Actually, our Sun is a rather common star. Although it is undoubtedly the primary cause of life on Earth, it is mostly unknown elsewhere in the cosmos. The Sun would be clearly visible to the human eye, unlike Proxima, even if you traveled 4 light-years away, the distance to the nearest star, Proxima Centauri. And as for the planets, well, Jupiter, being the most massive one, might be visible. 7. The solar system's future. We all understand that the Sun will eventually die, grow larger, and change into a red giant. Astronomers have pondered the true impact of a Sun-like star's demise on its planetary and lunar system for decades, particularly if any planets can survive the assault. We now have some concepts. A team from the University of Tasmania discovered a Jupiter-like exoplanet around a white dwarf not far from the galactic center. The team claims that the system they have found offers a look into the solar system's potential future. The outer planets may survive, but the terrestrial planets will most certainly perish due to the fading Sun. Additionally, this marks the discovery of a planet with an orbit similar to Jupiter. 8. The galactic center is not where we are. Actually, we've only been aware of our place in a much broader disk of stars orbiting a common core for the past century or so. It has historically been challenging to pinpoint our specific location because we are a part of it. But because of continued work, astronomers now understand where our Sun is located inside the galaxy. The solar system and Earth are situated approximately 25,000 light-years from the galactic center and 25,000 light-years from the rim of our Milky Way, which is a barred spiral galaxy. Consequently, we would be located around midway between the center and the outside of the Milky Way, if you were to imagine it as a large record. 9. The hottest planet is Venus. Did you know that? Despite Mercury being nearer to the Sun than Venus, Venus is the hottest planet in our solar system. Venus's surface reaches temperatures of roughly 900 degrees Fahrenheit, 475 degrees Celsius. You must use extreme caution since lead can melt at those temperatures. The surface is rust-colored, covered in thousands of massive volcanoes, strongly crushed mountains, and other geological features. Some volcanoes, according to scientists, may still be active. 10. The moon is evaporating. Yes, the moon is separating from Earth at a pace of roughly 3.78 centimeters each year. The interaction of the moon's gravity with the Earth's seas, also known as tide, is what causes the moon to steadily move away from the Earth. The gravitational pull of the moon on the Earth results in the movement of the oceans, which creates a tidal bulge. Then, because the Earth rotates faster than the moon revolves, this tidal bulge happens at a point in its orbit around the Earth that is just a little bit ahead of the moon. As a result, the Earth's interior experiences friction, which results in energy loss. A portion of this energy is transmitted into the motion of the moon's orbit, pushing it into an orbit that is further from Earth. Our moon is a special situation, but generally speaking, the satellite could potentially be migrating inwards based on specific factors, such as the object's period of revolution. Although it seems unbelievable and paradoxical, everything is actually encoded using tedious and exact mathematical calculations. And it is what gives it its beauty. Hey! Here's where the video ends. Thank you for viewing. If you liked the video, be sure to follow the channel. Possibly also enable the notifications. See you again soon.